Hello students, so we were discussing about the chapter 2 of the physics, that is about the human eye and the colorful world. So what we have seen in the previous lecture, we have gone through the discussion that is about the structure and parts of the human eye. So I hope this topic has been clear to you because this topic is very much important from the exam point of view. Directly 5-mark question can be asked from this topic. Now continuing with this lecture, we are going to discuss about the function of the human eye today. So today we are going to start our new topic that is about the function of human eye. Now, before starting the functioning of the human eye, let's discuss one more term that is known as a blind spot. So, firstly, let's discuss about the term that is the blind spot you can see in the structure of eye. Now, what is this blind spot? In the structure of eye, we have seen that the optic nerves are connected to a point with the part of the eye. So, the point where the optic nerves are connected to the eye, this part is known as our blind spot. And on that blind spot, you have seen in the structure of the eye, there is no retina. If there is no retina, there will be no formation of image on that blind spot, and every person has a blind spot in his or her eye, and you can analyze that blind spot by performing the simple activities. You can find those activities on the Google and try to perform that whether the blind spot is present in our eye or not. So you can perform these activities simply by searching on the internet. Now, this blind spot is actually a point. It is a point where optic nerves are connected to part of eye. And in this part, there is no retina. So, if there is no retina, there will be no image formation because image is going to be formed on retina only. So, this point will be known as a blind spot of the eye because there is no retina, there is no image formation on that part. So, that's why it is known as the blind spot. So, this is a very important term again, you can see. So, just note that part from here. Now, continuing with the functioning of the human eye, we have discussed parts and the structure of the human eye completely. Now, today we are going to deal with the functioning of human eye. So, the functioning of human eye is very simple and very short, and only 2 marks question can rise from it. So, you have to write only that part. So, let's deal with the functioning of human eye, but before that, just draw the structure of the eye we can draw. Now, this is our bulging part known as cornea. This is our pupil, and in this pupil a hole is situated that is of black color, and that will be known as iris. This is our crystalline lens. This is our lens. These are our optic nerves. And this is what? This is the retina where the image is going to be formed. So these are actually the parts of the human eye we have. This is iris, cornea, pupil, lens, optic nerves and retina. These are the important parts of the human eye. Now, how the image is going to be formed on the retina? Let's see here. Suppose I am taking any object here. This is the object I have taken. Now what will happen in this case? The light rays from this object is going to fall on cornea and it is going to detect that light. It means the bulging part which is outside the eyeball is going to capture these light rays. So light rays is firstly going to be fall on that part. Light rays is going to be fall on that part. Now, what pupil will do? Pupil will determine or detect the intensity of the light and iris will going to regulate that light rays and it will expand and contract accordingly to the amount of light falling on that. So, if the light rays is falling in that part, it will go through cornea. After that, it is going to the pupil and iris is located here which is going to contract and expand accordingly. Now, you can see that these are the amount of light rays passing through it, but iris will going to pass only the specific light through it. So you can see that a specific amount of light is going to pass through iris. This iris is not passing the whole light which is entering through the eye. It is passing only a specific amount of light that is falling into the eye. So it will pass the light through here and these ciliary muscles will expand and contract accordingly the light rays falling on it as it is attached to the crystalline lens. Now, after passing through iris, what will be the function of lens? The lens is going to refract these light rays and the image is going to form on the retina after refraction. So, this is the lens through which the light rays is going to pass and what you will get? You will get the image of the object like this here. So this is what? This is the image you are getting here. So this is object, this is image. So very simple to understand that whenever a light is going to fall on a cornea, the cornea will pass the 90% of the light to the pupil. The pupil will regulate the intensity of the light and it goes through iris. Iris will not going to pass the whole light. In fact, it is going to pass the specified light to the lens and lens is a crystalline lens which is a convex lens in our eye and it is going to perform the refraction. After refraction, an image is going to form on the retina. So this is the very simple functioning that how the functioning of human eye can occur. Now, what you will see that you are seeing that we are just getting the inverted image here. It is an inverted image here. So, whenever you see any object, whether you get the inverted image or not, if I am standing in front of you, I am looking or I am seeing any object in front of me as a real one or the inverted one. So, this is not actually the inverted image we are getting here. This is the image what the lens is forming. So, we are not looking through our eyes, we are actually looking through our brain because the eye is sending the electrical signals to the brain and brain is going to identify that image only. So, you can see that here we are getting the inverted image. So, that's why we are not seeing through our eyes, actually our brain is working and that the image that is formed on the retina is sent to the brain via these optic nerves which is going to perform the transmission of the signal into the brain. That's why we will get the inverted image of an object. So, it becomes very clear that the image is going to be formed on retina in the eye, but the brain is going to identify that image. Just like suppose a camera is capturing my image. So, camera is having an aperture. So this is going to capture my image. So if it is going to capture my image, the function of the camera is to just capture the image. It is not performing the other functions as well as. So same as our eye is just like a camera. It only going to focus the image, but the whole processing is done by the brain only. So the brain is going to identify the image that will be straight. And here the image formed is inverted because the eye lens have a convex lens which is going to form only real and inverted image. So this inverted image is made only because the lens in our eye is a convex lens. And what is the property of the convex lens? The convex lens is going to form real and inverted image. So this is the property of convex lens. So this topic is very interesting and I hope this is clear to you. Now proceeding to our further part, you can see that if I keep the object here and there, if I am going to move the object in left and right, suppose I am moving the object here and somewhat I am moving the object here. So whether you are moving the object anywhere, you can see that the image is always formed on the retina. This is a very important point, that whether you are moving the object to the left or right, you are always getting the image on the retina. And why is it so? It is so because that the image is going to be formed on retina because we are using here the lens and the ciliary muscles are attached to it. So you have discussed and you have know that we have a discussion in the previous lecture. We are using the glass lens. We have used the glass lens and the glass lens is forming the 6 images. You have seen that when you kept the image at focus, you will get the image at infinity. When you place the object at infinity, you will get the image at focus. When you place the object between f and 2f, you will get the image beyond 2f. So these are the few of the cases, that is the 6 ray diagrams we have considered there. So there we are using the glass lens and it is forming the image at different points. But now we are using the crystalline lens. You can see crystalline lens attached with the ciliary muscles. So wherever you keep the object in the left side or right side, you will always get the image at the retina only. And this is possible only because we are having a crystalline lens attached to the ciliary muscles. So this is another important function of the ciliary muscles you can see we have. So this is all about the functioning of the human eye. So this part is very important and the question is definitely going to be asked in your exam about that part. Now, continuing with that part, we have a new term that is about the persistence of vision. So we are going to deal with persistence of vision now. So the next thing is about persistence of vision. Now what is persistence of vision? Persistence of vision means whenever a light is going to fall on our cornea or on our eye, we can see that there is a refraction. Just because of that we are able to see the object. So the time for which the light will remain at our eye, it is only 1/16th of a second. So that will be known as the persistence of vision. So it means whenever a light is going to fall on our eye lens, it will remain only 1/16th of a second, which is a very short time. So this will be known as our persistence of vision. So the light falling on eye lens before refraction it will remain only for 1/16th of second. It is a very small time. You can see that for a very little time it will remain on our eye and that will be known as our persistence of vision. So this is another term apart from the blind spot we have seen here. Now let's begin with the another topic that is known as power of accommodation of eye, or simply what will be the accommodation of eye. You know that our eye lens is actually made up of the transparent, and we can say that it is formed of the fibrous material you can see. So this is a fibrous material, and this material you can see that it can expand and contract accordingly whenever a light ray is going to fall on that part. So you have analyzed that in a movie theater, when we are sitting here, there is a complete darkness, but when you came out, because of the sunlight, your eyes will not get open. This is a very common case. You have seen that from a dark room, whenever you are shifted from dark room to an open space, when there is a light, you can see that our eyes will not open completely. And why it is so? It is just because of that factor that is known as the accommodation of eye. So next thing is about power of accommodation of eye. Now what is this power of accommodation? The human eye has an capability to increase or decrease the focal length accordingly. So there is an increase or decrease in the focal length of the eye, so that will be known as our accommodation. So you can see that when our iris or our lens will become expand or contract, we can say that when this iris is relaxed, the lens will become thin, and when the lens become thin, the focal length is going to increase, and if focal length is increased, you can see the distant objects very clearly. So if you are able to see the distant object very clearly, it is just because of the one factor that the focal length is going to be increased. If the focal length is going to be increased or decreased, that will be known as the power of accommodation of eye. So what is the power of accommodation? The increase or decrease in the focal length of an eye, the increase and decrease in focal length of eye is known as power of accommodation. So that will be known as the power of accommodation of the human eye. Now we will simply draw a flow chart, and this is a mind map to remember all these things. So these things can be easily understood by you. Let's try to understand it in more easier ways. Now, you have a part in your eye that is iris. So this is our iris. Now what will happen? Either iris will get contract or relaxed. So two things can occur here. This iris is going to be relaxed or it may be contract. These can be the two cases you have. So this iris will get relaxed or it can be contract. These are the two things which can occur here. So when this iris get relaxed, the eye lens will going to become thin. So in this case, you can see that when iris get relaxed, eye lens become thin. Eye lens will become thinner. But when it contracts, you can see that the eye lens become thicker. Eye lens is going to be thicker. So these are the two things occurring here. When the iris become relaxed, eye lens will become thinner, and when the iris become contract, the eye lens will become thicker. So thinner and thicker, there are the two situations we have. So when this eye lens will become thinner, the focal length will going to increase, and if the focal length is increasing, you can see the distant object very clearly. So When this happening, that eye lens become thin, the focal length increases. Focal length increases. But when the lens become thick, the focal length decreases. The focal length decreases. And if the focal length is very large, it means when the focal length increases, you can see the distant objects clearly. You can see the distant objects clearly. And when the lens become thick, you can see the nearby objects clearly. So we can see the nearby objects clearly. So there are the two cases that if the focal length is increased or decreased, these things are happening. So this flow chart is going to tell you in the more simpler way that when the iris is contract or released, you can see that the lens will become thin and thick. When the lens become thin, the focal length is increased, and if the focal length is large, you can see the distant objects very clearly. And if the lens is thick, the thickness is increasing in the case of the lens. So focal length is going to be decreased, and if the focal length is decreased, you can see that you can see only nearby objects clearly. So there is a point or there is a limit, you can see a nearby and the far point very clearly. So the least distance up to which you can see the object clearly is only 25 centimeter. So 25 centimeter is a least point of distinct vision where you can see an object very clearly. And what will be the far point of the eye? The far point for the eye will be infinity. At the infinity, you can see very clearly. So the persistence or so the capability of the human eye to see an object always going to lie between 25 centimeter to infinity. So these are the 2 points you have. So firstly, just learn this mind map. This is very important. So this topic has been cleared to you just by learning this. Now, one thing it has been cleared that the focal length can be increased or decreased, and that will be the power of accommodation of an eye. Now, we have the 2 points here. The first point is about what is the least distance of, or we can see that least point of distinct vision. So what will be the least point of distinct vision? It is the point up to which our eye is able to see very clearly. So this will be known as the least point of distinct vision. So our eye is able to see completely up to only 25 centimeter. The nearby objects we are seeing only at the 25 centimeter. You have just see that when you are just holding a paper, written something on it, when you are keeping closer it to your eye, you can see that the image is getting blurred. You cannot able to read the objects very, very clearly. So what must be the least distance of the vision? It must be 25 centimeters. So what you have to do? You have to kept a paper on which the letters are written at the 25 centimeter distance. So if you are doing this, the 25 centimeter distance will be your least distance of vision, or you can see that the least point of distinct vision. So you have to kept it at a distance of 25 centimeter. So our eye is able to clearly see the object at 25 centimeter. So this will be the near point for the eye, and it will see the object at far point, that is known as the infinite. So you have the 2 points, near point and far point. So these are the 2 points we have for the eye. So the near point up to which the eye is able to see clearly is up to 25 centimeter. So the near point is 25 centimeter, and the far point is a point up to which you can see at the infinity. So the far point of the eye will be infinity. So the range of vision for the human eye is going to lie between 25 centimeter to infinity, you can say. So this is a distinct point of the vision for the human eye. One is for the near point and one is for the far point. Now, one thing you have observed that the people in the old age have the lenses in their eye which becomes milky and cloudy. Have you observed that? If you have not observed that, just do a simple observation. In the old age, see the people have the lens which will become milky and cloudy. So this condition is known as a cataract, and what they have to do, they have to replace their lenses by performing a surgery that is known as the cataract. Cataract is simply a surgery which is performed in the old age when the people have the lenses that will become the milky and cloudy and they are not going to see any object clearly. Either they will lose their eyesight. So this condition is known as cataract. So one more important point is there, that is about the cataract. Now what is this cataract? Cataract is that people in the old age have their eye lens either milky or cloudy. It means they will see something blur. So if this eye lens will become milky or cloudy, they will not see objects clearly. And they can be corrected by performing a surgery known as cataract. So when the people in the old age will see the things milky and cloudy because their lens will become cloudy, this condition is known as the cataract we have. So this lecture is all about the power and accommodation of eye. Again, this is a very important and interesting topic. So go through this video lecture very clearly. Now, the structure of human eye and its part and about its working has been completed. Now, what are the defects in the human eye and what are their correction methods we will discuss in the next lecture. So thank you so much and have a nice day.